In the previous video, we saw how to carry out mathematical operations using NumPy arrays. Now the question that we ask ourselves is what happens if in any of those operations the arrays that participate in them don't have the same shape, if they don't fit with one another. For that, NumPy has certain broadcasting rules. That is, it will try to interpret what we want to do when we give it arrays with different shapes. Let us see some examples. We'll use the range method to create an array with 10 elements, from 0 to 9. And we're going to declare a variable called factor, which will be equal to 2. Now we'll multiply the range array by 2. What happened here? Well, what happened is that NumPy has applied a broadcasting rule, according to which, if it sees a single element in a dimension, it will assume that that element has to be applied to each one of the elements of the other array in that dimension. So NumPy took the number 2 and multiplied it by each of these elements. Let's see another example. Let's create an array called A with 16 elements. And let's reshape this array to have 4 rows and 4 columns. Now let's create another array called B, which will have 4 elements and a single dimension. And the value of those elements will be 2. Let's see these two arrays. As you can see, A is a 4x4 array with 4 rows and 4 columns. And B is a vector with 4 elements. What happens if we add this array and this vector? Well, what happens is that NumPy is going to understand that what we want is to take the B vector and add it to the first row of the two-dimensional array. Then it will add the B vector to the second row, then to the third row, and then to the fourth. That is, NumPy will see that the B array only has one element in the row dimension, and it will assume that it has to apply this single element to each one of the rows of the other array. Let's see it with another example. Let's create an array called A using the range method, and let's give it 4 elements. Let's also create another array called B and give it 4 elements. But we are going to change the shape of the B array. The reshape method tells NumPy that we want the array B to have a single column and no matter how many rows. So what NumPy did is take a row vector and convert it into a single column. And for that it has to give it 4 rows. What happens if we add A and B? Well, what happens is that NumPy would apply the same broadcasting rules that we saw in the previous examples. For example, NumPy will see that A has a single row, but B has 4. And A has 4 columns, and B has only 1. So NumPy will take the first element of A and add it to each element of B. Then it will take the second element of A and it will add it to every element of B. Then the third and then the fourth. And the result will be a 4x4 matrix.